All right, well, I appreciate being here. It's a big crowd. Remember the first time I came to the show, I think they could have fit at those two tables. Life has changed since it was M2M and telemetry, and now we're into the new world of IoT. So my presentation is supposed to be about the hardware part of this business and making sure that we make good choices. So as you look at this video, you probably think, what in the world are we talking about here? There's a lot of people in this room that may play video games, and I guarantee there's children of a lot of people in this room that play video games. But as that industry was beginning and evolving, it was very fractionalized. There were people out there writing their own code, trying to build their own games, building their own boxes, trying to create all this stuff from scratch. I had friends that were constantly busy in their garage or their basement, building things, trying to create what they wouldn't have called the killer app, but today we would call the killer app. And basically what it came down to is someone had to crack the code to build a platform that would be a platform that could last a very long time, that you could build upon by making the right fundamental choices from the very beginning. And there were dozens of companies trying to do that, but in 1983 there was one in particular that did it. It was Nintendo. So since 1983, Nintendo has sold 4 billion games. If they were to lose $250 million a year in from now until 2050, they'd still have cash in the bank. They've done a pretty good job of building an extraordinary company with a game console, because they made some good, wise choices in the beginning and then built upon it. And it doesn't take everybody saying, oh, you got to have so many different apps and everything. You can actually do it with a killer app. We've heard a lot of talk about smart cities and different things. You don't have to have 50 applications to make something work. Nintendo's top 2 products bring in more revenue than the other 98% of the company combined. So you can have a killer app, and that's a lot of what IoT is about. So as IoT, which we believe is really at an inflection point right now, and we're starting to hit critical mass as an industry, you're starting to see different segments that are really starting to come forth. As I said, we hear about smart cities all the time. We're the connected automobile. You're talking about all sorts of things that are happening throughout the infrastructure. We're talking about safety and security of our roadways and our economy and all these different segments. The challenge is if you don't build with the right platform to begin with, the right device, the right choices on connectivity, the right choices on what the foundation of that is, you're going to have problems long term. And that's pretty much what I'm here to talk about, because we can talk all day long about all the cool apps people have, but there have been some challenges in the space and some stops and starts. And we are at that inflection point where I truly do believe we're going to get to that trillion machines. But you can't get to a trillion machines if you have to tear out all your infrastructure and throw it in the trash every 7 to 10 years because somebody decided to end of life your product, your technologies, or whatever. So the first piece of this equation is talking about what type of connectivity you're going to have for that device. As you look at the device, there are a lot of choices out there today. Cellular has a big piece of the business. 2G was the answer. I remember when we started with 2G, it was in the space then. Then it was 3G was the answer. Then it was 4G. Now it's, well, 4G isn't going to meet our needs, so it's 5G. But really 5G is, well, let's see, LTE 1, LTE 2, LTE M, Cat 1, Cat 0. Now it's NB-IoT is what's coming next. We've been through so many alphabet soups in the last 24 months, it's hard to keep track. And the reason is we're taking a technology that is built for this and really, really good at it for human interface, and we're trying to shove it into the machine marketplace. Cellular's built for a human interface and does it great. We love it. We love to go from 2G to 3G to 4G, and we can't wait to get our 5G phones because we can walk in the store and get more every time. But if you just deployed it in your infrastructure, you don't want to go tear it out. In most solutions, it costs more money to roll a truck than the money they'll save for the first few years. They may never get to a positive ROI if they got to keep replacing stuff. So this is a very, very critical decision. Another part of it is the fact that if you want to have a global solution, which is the only thing that's going to get us trillion machines, is truly global solutions, you have to have 16 different radios to support cellular. Who's going to put 16 radios in a device? It's cost prohibitive, size prohibitive. So what do? You got 16 SKUs. Then don't even think about how many carrier contracts you have to sign and all the certifications and all the process you have to go through. So this is a big challenge and something that's hard to deal with on the cellular side. There are other technologies that you would call in a low-power technology type space. They're not as bad as cellular. You need about 6 different SKUs to cover the world. But again, that's a challenge. What you need is one SKU that you can build one time for your application and sell it in every country on the planet. That's how you build an ecosystem where you can get the ROI and the returns to whatever it is you're doing. And because of that, we've been able to have great success with companies like Halliburton, who has been using oil and gas solutions in the US and has now signed a global contract with our RPMA technology at Ingenu for their whole oil and gas production globally, because they don't have to reinvent the wheel. They can use the same thing everywhere. And we have many other global brands that are working on projects that are very similar. Another part of it is, again, everything was built for human communication. 2 people talking to each other, good. Someone can say something, you nod yes, or you're talking on the phone, you can comment back, or you're texting, you text back. Well, cellular networks are built to mirror human communication. You can talk back and forth, text back and forth. For machines, when a machine sends a message, you have no way of knowing that the message got there. There's no acknowledgement of that unless you build that into your solution. There are some wireless technologies where you can't communicate back to the machine, so it's impossible to know that the data ever got through. So that's a little difficult. Or if it's a two-way communication, you have to spend data, time, money, and energy to go back and forth to see if it's actually communicating and doing what it's done. What you need is a technology that no matter what the environment is, and no matter what the vertical it is, we heard a lot about verticals and industries, no matter what it is, when you send that message, you know 100% of the time if it got through or not, because there's an acknowledgement of that message. Sounds like a simple thing, but it's a big deal when you start talking about machines and what machines are doing in all the different vertical spaces. And this is a big one. I've been hearing for years, what's going to change battery life? And I have sat on multiple panels for 16 years in this space, and everybody's always said, somebody's going to invent a new battery. Well, I still haven't seen anybody invent a battery yet that gives us the battery life that we need in the wireless world in order to communicate with these devices wherever they are. It doesn't exist. It's gotten a little bit better, but we're talking fractionally better. But what if there was a network where you could put a device on a container, ship that container anywhere in the world, ping it every day, and that battery would last 20 years on that container? Now you have a model that changes everything. Or we have, I'll go back to Halliburton with Wellaware, our solution partner in the oil and gas. Everybody says, well, you only need power in the middle of nowhere. Actually, in Los Angeles, I don't know if anybody grew up in LA like I did, but back when I was growing up, there were wells pumping all over West LA and the hills in West LA. Those wells are all capped off now. And the state of California has required that they pump water back into the ground to stabilize the ground underneath because of all the seismic activity and everything else. They want them to replace the oil with water. Well, the challenge is they had no way to monitor how much water was going back into the ground, so they were paying $900,000 a month in fines. It was cheaper to pay $900,000 a month in fines than come up with a solution to show that they're pumping the water into the ground. One of the reasons they had a challenge is they had no power. And you say, it's in the middle of Los Angeles. How tough can it be? Well, where all these wells were built, and when they were built, there wasn't a bunch of power everywhere. It's going to cost them so much money to bring the power in that it just absolutely didn't make sense. So here in a big core city, they had no power. So they went and they put the well-aware equipment on those wells, just reversed the measuring from how much oil they pump out to how much water they pump back in. The way they designed it and the amount of information and data they're transmitting, the batteries will last 10 years on those wellheads. So they go once, they put it in, they don't touch it, they come back, they save $900,000 a month. They managed to cover, at that point, before we built our whole Los Angeles network, they covered all those wells with one tower, and I'll talk about that in a minute. But I mean, battery life changes everything. Over my career, we've launched, and I see some of the people out there, we've launched it with 3 pet trackers in the last 15 years. The dog trackers were going to be the ultimate app, right? We're going to sell millions of these suckers. Well, there were problems. Number 1, they were too expensive. Number 2, they were too big. And number 3, who wants to plug the collar in every night on your dog? Well, what if it was considerably less money, considerably smaller, and even with a really small collar and a very small battery, you only had to plug it in every quarter or two? Changes everything. And now you have people elsewhere in the ecosystem that aren't trying to do a startup, but actually own that part of the ecosystem that are launching products with our technology because it finally makes sense. So you have to change the paradigm, and you only do that by changing the underlying technology. So as you go to build the device, if you have an RPMA radio in that device, all of a sudden it changes everything as far as the lifetime of the use of that device without touching again. I'll give you one other example. It's in the Niger River Delta in Nigeria. Some of you may have seen our announcement with Shell Oil. They were trying to cover all their oil and gas production assets in the Niger River Delta. Well, first off, there is no people there. It's just a bunch of machines, so there's no cellular coverage. Secondly, they have virtually no power out there anywhere, so satellite wouldn't work because they needed a bunch of power. They decided to do RPMA and built an RPMA network in 90 days, spent $86,000, and they saved $1 million in losses in the first year. It's a pretty good ROI. The technology is simple, and it works very well, and it gives you the efficiencies that you need to really make changes in the way this business operates. Next is security. We hear an awful lot about security. Everybody says, well, it's up to the device. You got to have it at the device. Well, you do have to have it at the device level. We just see a major denial of service because people hack DVRs because no one changed the password from password on DVRs. So the device is important, but the network layer is critically important too. And there are networks out there that do not have network security. We have networks running nuclear power plants. So I'd say we've got the security down pretty darn well. But this is an important part when you are talking about building your device, making sure that you're going to have the longevity, that while that's out there for years or even decades, that you have the ability to be able to support that in a very secure environment. Because as it comes down the path, having been in this industry a long time, if it gets hacked, the guy that builds the device gets blamed first. If it loses connectivity, the guy that builds the network gets blamed first. But the bottom line is, you have to have security at every single layer, and it's critically important. The IoT industry has been running below the radar for quite a while. Those days are gone. Everybody talks about IoT all the time, even though most of them don't know what it is, but I can tell you this, the hackers in the world are just drooling right now to get their hands on this stuff. And it's absolutely critical that we build secure systems and networks. Because as we keep talking about the Internet of Things or the Internet of Everything, and we're connecting so many different parts of our lives, from our business to our homes to members of our family and everything else, all we need is one entry point to really start to wreak havoc on what's going on in our life. So it's absolutely critical that you make the choices when you are doing this. You're going to have a very, very secure partner in order to move forward. The next step, we talk about so many industries and verticals. So many times we talk about stuff that's city core centric. But the bottom line is a lot of the industrial things we talk about all the time are far, far from the core city areas. In the United States, the cellular carriers cover 96 to 98% of the US population. Yet, today, 25% of the United States acreage still has zero coverage. In that area, there's a lot of mines, there's a lot of agriculture, there's a lot of oil and gas, there's a lot of energy production, a lot of energy distribution. All of these areas, when we start making them smarter and we start connecting them to the Internet of Things, they need coverage. If you can't get the coverage there, you're screwed. You're never going to get coverage from NB-IoT because NB-IoT has to run on LTE. And they're never going to build an LTE tower unless they're going to get $80 ARPU out of all of us. They're not going to build it for $1 a month. It will never happen. So if you want an NB-IoT out for your agriculture solution or some of these other remote things, you got a serious problem. We've had great success in this space because of how well our technology works, but how expansive the coverage works. We can get 300 square miles coverage out of a tower. We like to joke that we've got the only network on the North Slope. We're covering all the oil and gas production up in Prudhoe Bay, up in there, and there's no coverage of anything else, but we're covering it all up there because all it took was 2 towers. The city of Phoenix has 1,600 cellular towers, we have 8, and our coverage is better. Okay? So we have the ability to go out into areas that don't make financial sense for cellular really ever, and it's a viable business model for our technology. So as you look at some of this that's come by, agriculture has been a big win for us. I don't know if you saw our announcement recently, but U.S. Sugar is the largest producer of sugar there is. They have a lot of sugarcane fields, and 2 things that they've been needing to do for many years is monitor the soil for nutrient depletion and water for water management. Water's getting scarce and expensive. They can never monitor the soil and the water because no technology will penetrate sugarcane because it's so dense. It's thick, it's full of water. They've tried everything and nothing would work. They piloted RPMA and immediately signed a contract to cover all their sugarcane production with RPMA technology. It worked flawlessly. So it's about coverage, it's about penetration, it's about cost to build a network. If you have to put in 100 more sites, do the math, it gets a little scary pretty quickly. The bottom line here is RPMA, which stands for Random Phase Multiple Access. Don't have to remember that right now, you can just go to our website. But RPMA is the only technology that's ever been built from the ground up to be a machine-to-machine communication over wide areas and to do everything machines need to do. I've been a cellular guy for over 15 years. I understand the cellular business, and the cellular business does an extraordinary job of doing things really well that they do well. But I also have been in the IoT part of the business for a very long time, and I know what the challenges are. The challenges are many. And what RPMA does is it turns the whole physics on its ear to give you a complete opposite benefit to the challenges, whether it's greater battery life, or whether it's greater coverage, whether it's lower costs of deployment, whether it's dealing with actual coverage of interference. You know, I don't care how good your LTE network is. How many of you have had 5 bars at a football game and you can't send out a text or get a phone call? You got 5 bars. You think your machines that are on that network are communicating? Not a chance, okay? You don't have to deal with that on RPMA because you don't have that kind of interference into what you're doing. The other thing is you always need to talk to the devices. It's important to be able to talk to them, change what information you need, how much information you need, what time you need that information, maybe do firmware updates. So thinking ahead, it's 2 channels, a down channel and an up channel. You know, when you're on a phone talking to somebody, you talk over each other and you cancel each other out. That happens with your machines if you try to do firmware upgrades while the machine is there sending you information. You cancel out and neither one of them works. With RPMA, you got a down channel and you got an up channel. You can do both at the exact same time. Again, these are some pretty bright minds that thought from the very, very beginning, what do the machines need that human beings don't? And built it based upon that. We're building the U.S. network. We're doing very well. We're over 40 markets live in the U.S. We're adding towers every day. I think today I got 3 more tower announcements. They're just constantly coming up and coming on. And we're licensing the technology to the rest of the world. We have over 50 countries in the mix. We have networks running on 5 continents, networks under construction on 6 continents. And within about 24 months, we should cover about 3/4 of the world population. It will be the first true global solution for IoT connectivity. And that's it. I'm going to leave 6 minutes for questions because they told me to leave time for questions. So I don't know where you are, Carl, or who has a mic or anything else. Okay. Are there any questions?
Yes. Okay, so we're going to split
up. You have
up.
to wait, Carl.
Question, how does RPMA compare to LoRa?
Good question. LoRa's a good technology that can satisfy a sliver of the market. If you look at the global market, about 86% of the machines in the world send 3 megs of data a month or less. Massive amount of the machines. We can support that. LoRa can support a small segment of that. It really wasn't designed to be the whole wide area technology that we have. Where we put a tower, they have to put many, many more towers. More cost of infrastructure, whether it's CapEx or OpEx. We have much more data throughput, both downlink and uplink, so you can hit this amount of percentage of the network, of the potential marketplace. So it's just a much more stronger, more powerful technology. And it's proven. We've got networks that have been running for 9 years around the world. It's not a science project. This is not what we say it will do. It's what it's doing today all over the world every day.
How about Sigfox? How do you compare to them in their deployment?
Where's that question?
Over here. They seem to have a head start, right? They're out there.
Sigfox had a great head start. They're my best sales machine. I hate to tell Tom Greger and his team, but my best sales machine is Sigfox because they've gone out and got the whole world excited about LPWA and alternate technologies. I'm not going to sit here and trash them, although it's tempting. But bottom line, you can go to our website and you can see ABI reports, all sorts of white pages, all sorts of independent analytics about what can be done. But I can tell you this, Laura just blows away Sigfox. And there are some significant challenges to what they can do. And they're after a small sliver, and that's fine. But we expect to be able to support the vast majority of machines in the world. When there's 1 trillion machines, and if 86% of that market's addressable to us, that's kind of what I'm interested in. So we are a very strong, viable, working technology, and I'll leave it at that. I see a hand waving over there, sort of in the light.
Yes.
Yes?
Is it based on ISM bands or just frequencies?
2.4. So it's the only spectrum that's free in every country on the planet, available in any country on the planet, unlicensed on every country on the planet. And everybody goes, well, why in the world did you pick 2.4? Well, those were the reasons. We own a bunch of IP that allows us to communicate very effectively in there. And that means not only do we not let ourselves be interfered on, but we don't interfere. We're a good neighbor. Everywhere we have networks, what am I doing here? Oh, I see you waving over here, Carl. So we have these networks running all over the world. We've got networks in LA and Seoul and Tokyo. I mean, they're sort of interference-rich environments, and they work very well every day and do well. But I mean, 2.4 is one of the keys to this. Because again, it is the only spectrum where you can build a SKU in the United States and sell it in the world, or a SKU in South Africa and sell it in the world, or develop an application in China and sell it in the world. All places where we have networks today. So it's really critical, important that we have simplified this. I mean, Ingenu means simply genius. It's simply genius because it has taken this entire industry and taken it down to the most simple common denominator possible, so that we can get to 1 trillion machines and build an ecosystem where we can all have success and make some money on this thing. So, is that it, Carl, or are you going to ask your question?
One more.
Just one quick question about mining. Above the mine, above ground, sounds like a very viable solution, but what about under the ground?
Great question. It's kind of funny you ask that because we have a partner in Asia that they build mine networks. And they are one of our network partners. So they're very, very familiar with that. I could tell you this, our penetration is amazing. People are shocked when they do the tests of it. Like I said, the sugarcane, it was the first thing that ever penetrated. Can we penetrate miles under the earth? Heck no. But we actually have oil and water meter applications where it's penetrating underground and getting to those meters a few feet underground very, very well. They are building some of our technology with these mines with our partner in China, and they're just kind of going to daisy chain a little bit in the mine. But because it goes so far and it's such a good, strong signal, they can do that, and it's an effective mine technology where nothing else really works in that environment.
So I get the benefit of the last question.
Okay.
So back in the days when we were all deploying fiber and you were deploying wireless networks, we all went to the football cities and the big yellow parts on the map and decided where we were plotting things.
Yeah.
Tell me how you guys do your network planning.
Great question, Carl. Well, been in this business for a long time, have supported thousands of customers in this business. We kind of know where they are, we know where their needs are, and we've kind of done our build strategy based upon where we know the quickest customers are. We've also gotten some significant contracts already, some of which I've mentioned, some of which I have not. And so we're following their needs geographically. So some people might look at our market announcements and go, this doesn't make any sense. It's kind of all here and then hopscotch there. There is a reason that we're going the way we're going, and it's because what all of our partners and our customers and solution providers need. And it's not all about the NFL cities. This year, we will cover a vast majority of the United States, but we won't cover all the NFL cities because there are areas that we can cover tremendously. We already cover 56, 57% of all U.S. and oil gas production where there is absolutely no cellular. We cover virtually all of Texas, almost all of Florida, which is good for sugarcane production. Southern California, and if you go across the south, we've got most of the southern U.S., but then it's kind of interesting based upon our customers' needs as we go geographically out from there.
And that, I'm afraid, is all we have time for. Please, folks, a nice round of applause for John Horn.